Wasabi, you guys. I almost forgot to answer the most important question. What is my favorite integral? Now, first of all, I'll go ahead and I'll first show you the integral before. It is this Norwegian substitution integral. This will forever be my favorite integral. Look how sinister that looks, right? If you show this to anyone, even to a competitive mathlete, you know, this looks daunting, right? Until you know the solution to this, or for those who have Math Olympiad background, you already know how this kind of works, only because of algebra equations and stuff. But here, for those who are new, those who aren't Math Olympiads, if you just look at this, it just looks like non-elementary. But this is a very simple U substitution, and all you had to do, again, it's one of these amazing things where it's like, once you see the solution, you can't unsee it. And this beauty here can be easily solved by dividing 4 to the power of x to top and bottom. So 6 over 4 is 3 halves to the power of x. This is 1. And now 9 over 4 is 3 halves to the power of 2x. Now you can easily see, this is just letting u equal 3 over 2 to the power of x. And you can easily see that this is, it is a basic U substitution after all. It's just arctan. You see how awesome that is? From here, this scary looking integral here, right? But it's just a simple U substitution. So here, this is just simply equal to the inverse tangent of 3 halves to the power of x over ln of 3 halves plus c. Okay, so this is it's very, very beautiful, very sneaky yet very simple. So this is definitely one of my favorite integrals. Now, however, this is currently no longer my favorite integral no more, because I have a favorite integral now. Biasly, an integral that I've made that's now my #1 favorite integral. I'm too lazy to grab the original source, so I just found a picture of my own cat. And it's this. This is my #1 favorite integral out of all integrals. You know, even though I made it out of all integrals, you know, this is my #1 favorite integral ever. Okay, and I can kind of show you how to solve this because it is piecewise. Even though I hate piecewise integrals, this is ironically my favorite #1. So, how do you solve this? Well, unfortunately, we have to solve this manually, right? If we go from 1 to 2, let's see. Or actually, I think it would be easier. Yeah, I would think it would be easier to go from 1 to 4. Oh, actually, no, I lied. I'm sorry. The reason why I have to go from 1 to 2, you have to be very careful. This is not square rooted, right? This is not a square root. So I think it's better if I do it in a list, like this, from 1 to 2, right? Then what we have is this is now from 1 to 2, this is going to be like 1 mod 1 is equal to, is that just 0? I think that's just 0, yeah. So that's just 0, okay. And then from 2 to 3, 2 to 3, if we go from 2 to 3, square root of 2, that's just gonna be 1 mod 2 is just 1 mod 3 is also 1, and then if we reach to 4, right, So this means that this whole portion here is going to equal to 1. And then after 4, this is now going to be 2. So we get 2 mod 4, 2 mod 5, 2 mod 6. I think it's just going to be 2 all the way until we hit 9. Yeah. Until we hit 9, it's just going to be a bunch of 2 mod whatever numbers, right? And think of it like this, right? 2 mod of, that's bad notation. 2 mod of some integer greater than 2, it's just going to be 2. Okay, so think of it like that. So because we're dealing with our modulo is now bigger than this, now it's just a lot easier to, now we just only focus on this portion. So 9 to 16, it's going to be 3, right? It's just going to be 3 mod whatever. And then at 16 to 25, it's just going to be 4 mod whatever, right? Because this side here is going to be bigger than this. So that's why we only just pay attention to this. Because it's just going to congruent to this, since this is bigger. So because of that, we just get this. This is pretty much our answer. So this is 0. Here we have 4 minus 2, which is 2. 2 times 9 minus 4 is 5. 3 times 16 minus 9 is 7. Then 4 times 25 minus 16 is 9. So this is our answer here. We have 2 plus, or 12 to combine this. We have 12, 21, 36. Yeah. As you can see, we have our final answer. 69! Isn't that nice? I'm very sorry. but admit it. You know, like, come on. Like, this is literally the nicest integral ever. A little too nice. Fun fact, I actually did get a warning from a professor, or someone, I don't know. But this was projected in UC Berkeley Integration Bee, and I got a warning. Yeah, I cannot make funny integrals like that. That was bad. But it's okay. But this is definitely the nicest integral I've ever created, and it is now my #1 favorite integral so far in my life. Out of all integrals I've seen, this is my #1 favorite. Okay? And this might be your #1 favorite as well. Now that you know how to do some piecewise integration a little bit. But yeah, naturally, usually the normal way to solve this, it's just, you know, you go from 1 to 2, and you test out, okay, between intervals 1 to 2, 1 mod 1, that's, you know, 0, and then you just kind of continue 2 to 4, right? If I plug in, well, it's always going to be 1 mod 2, 3, right? It's just going to equal to 1, right? And then you keep going from 4 to 5, right? Here it's the square root of 4 or whatever in this interval, like let's say 6, right? If you plug in 6, square root of 6, you floor it down, it's just going to equal to 2, right? Always. And then 2 mod 4, 5, 6, 7, 8, 9. No matter what it is, it's just you're gonna keep getting congruence of 2, and so you might as well just combine it and, you know, go from 4 to 9 rather than going like 4 to 5, 5 to 6. That's a bad 5. You know, 6 to 7. Instead of writing it like this, you could just go like this instead. So that's why this is the normal way, but I'm too lazy to rewrite this whole integrand, and so that's why I do it in a list like this. Just because it's just a lot faster to write. Okay? So, I just want to recall that. This is just my lazy way of doing the integrands. Okay? Alright. I hope that was entertaining. Now you know how to solve this, my number one favorite integral. And yeah, thank you guys so much for watching, and I'll see you guys in the next video. See ya.